Hi everyone. In this video, I'll be presenting a way to solve many types of problems that require divisibility. So first, let's take a look at problem number 1. There are between 100 and 110 cards in a collection of cards. If they're counted 3 at a time, there's 2 left over. But if they're counted 4 at a time, there's 1 left over. How many cards in the collection? First, we're going to need the rule of divisibility by 3. The rule states that if the sum of the digits of the integer is divisible by 3, then the integer itself is also divisible by 3. An example of this would be 27. When you add 2 plus 7, you get 9, a multiple of 3, which means 27 is also divisible by 3. Now, logically, out of all these 5 options, when you subtract 2, you would get a multiple of 3. So when you do it to each of these numbers, you get that the possibilities for the numbers are only 101 and 107, because only these numbers, when 2 is subtracted from it, gives us a multiple of 3. For this problem, we're also going to need the rule of divisibility by 4. The rule states that if the number formed by the last 2 digits is divisible by 4, then it is also divisible by 4. For example, 240. When you look at the 2 last numbers, 40, you get that 40 is divisible by 4, which means 240 also is. Now, if you look back at these 5 options, you can use this rule to rule out some of these numbers. So the initial problem also stated that the number, when divided by 4, gave us a remainder of 1, which means when 1 is subtracted from one of these numbers, it should give us a multiple of 4. So once you try it with each of these numbers, you realize that 100 and 109 are the only options, because when 1 is removed from 101, you get 100, which is divisible by 4. It also applies to 109. So the answer for problem 1 was the intersection of set 101 and 107. That was for the divisibility by 3, and set 101 and 109, which is for the divisibility by 4, which is A101 because it appears in both of these sets. Now for problem 2, if n is a prime number greater than 3, what is the remainder when n squared is divided by 12? Alright, so for this question, we're also going to have to use some rules. So rule number 1, if n is a natural number and it is not divisible by 3, then n squared divided by 3 gives us a remainder of 1. This applies to any number you can think of. For example, 4. 4 is a natural number and is not divisible by 3. So when 4 squared is divided by 3, so 16 is divided by 3, the remainder is 1. Same thing with 5, 7, 8, 10, 11, and so on. Rule number 2, if n is an odd number, then n squared divided by 4 gives a remainder of 1. We can try it with any number you can think of. So for example, 3. No, it works with every number, even 1. But for the sake of this question, we're going to use 3. If 3 squared is divided by 4, the remainder is 1. So when 9 is divided by 4, the remainder should be 1, and it is. So the answer for this problem is that for the rule of divisibility by 12, the number that fulfills the divisibility of rule both 3 and 4 is divisible by 12 as well. So since prime number satisfies the condition for rule 1 and 2 of divisibility by n squared, the answer is B1. Of course, we could also solve the problem by selecting a number and try. So what this means is that when a rule is when a number is can be divided by 12, it can be divided by 3 and 4 as well. And since a prime number that we're talking about satisfies the conditions for rule 1 and 2 of divisibility by n of n squared, the answer is B1. So now we made a grid for every number and its rules for its divisibilities. So first, for number 2, if the last digit of the number is even, then it is divisible by 2. So for example, 54, 4 is divisible by 2, so 54 also is. So basically every even number. For 3, if the sum of all digits of the number is divisible by 3, then it is divisible by 3. So 1 plus 4 plus 1 gives us 6. 6 is divisible by 3, so 141 also is. For number 4, if the last two digits of the number is divisible by 4, then it is divisible by 4. So 32 is divisible by 4, so 132 also is. For 5, if the last digit of the number is 0 or 5. For 6, if it follows the rules for number 2 and 3. So if it's even, for example, and the sum is divisible by 3. For 7, if the difference between twice the units digit of the given number and the remaining part of the given number is equal to 0 or a multiple of 7, then it is divisible by 7. So, for example, 161. Twice of the units digit is 2, and the remaining part is 16. 16 times 2 gives us 14, a multiple of 7. That means 161 is a multiple of 7 also. For example, 49. 49, so twice the units digit is 18. 18 minus the rest of the number is 18 minus 4 gives us 14. So it also works both ways. It's basically the bigger number minus the smaller number. For 8, the last three digits of the given number is divisible by 8. So for example, 7,320. We know 320 is divisible by 8, so 7,320 also is. So now for 9, if the sum of all the digits of a given number is divisible by 9, then it is divisible by 9. Basically the same as 3. For 10, if the last digit of the number is 0, then it is divisible by 10. For 11, if the difference between the sum of the odd digits positions and the sum of the even digits positions is divisible by 11, then the number is divisible by 11. So the keyword here is positions. It doesn't matter which the number itself, whether it's even or odd, but its order basically. So for example, by odd digits position, they mean 8, 4, and 3, and even digits positions, they mean 1, 1, and 2. So here, the sum of odd digits positions are 8 plus 4, so 12 plus 3, 15, minus 1 plus 1 plus 2, so 4. 15 minus 4 gives us 11, and 11 is divisible by itself, so means this number is divisible by 11. For number 12, if the number follows the divisibility test of both 3 and 4, then it is divisible by 12. For 13, if the sum of the product of the last digit with 4 and the number formed by the remaining digits is divisible by 13, then it is divisible by 13. So it sounds complicated, but it's not. So basically, calculate the product of the last digit with 4. 1 times 4 gives us 4. Now calculate the sum of 4 plus the rest. So 4 plus 35 gives us 39, which is divisible by 13. For 14, if the number is divisible by both 2 and 7. For 15, if the number is divisible by both 3 and 5. And for 16, if the last 4 digits of the number is divisible by 16, then it's also divisible by 16. For 17, if the difference between the multiplication of the last digit by 5 and the number formed by the remaining digits is divisible by 17, then it is divisible by 17. For example, 391. The difference between first the multiplication of the last digit by 5, so 1 times 5 gives us 5, and the number formed by the remaining digits, so 39. 39 minus 5 gives us 34, which is divisible by 17. So 391 also is. For 18, if the number is divisible by both 2 and 9. For 19, if the sum of the product of its last digit with 2 and the number formed by the remaining digits is divisible by 19, then it is also divisible by 19. So the sum of the product of the last digit with 2, so 141 for example, the last digit is 1 times 2 gives us 2, and the sum of this product and the number formed by the remaining digits, so for example 17 plus 2 gives us 19, which means 19 is divisible by 19. For 20, if the last two digits of the given number is divisible by 20. For 21, if the number is divisible by both 3 and 7. For 22, if the number is divisible by 2 and 11. For number 23, if the sum of the product of the last digit was 7 and the number formed by the remaining digits is divisible by 23, then it is divisible by 23. So the last digit here is 1 times 7 gives us 7, and the sum of 39, so the remaining digits, plus 7 gives us 46, and 46 is divisible by 23, which means 391 is also divisible by 23. For 24, if the number is divisible by both 3 and 8. For 25, if the last digits of the number are divisible by 25, then it is divisible by 25. So these are all the rules up till 25. There's no need to memorize them, but maybe just like understand them and why they work. So yes, thank you for listening and have a great day.